All right, so in this example problem, we're given a function. So this is a potential function that's a function of x and y. And we want to find the magnitude and direction of the electric field at two specific points. So when x is 0.5 and y is 1 meter. All right, so in order to get the electric field from a potential function, we have to take the partial derivative. And for our first term, in order to get our x term, we have to take the partial derivative in terms of x. So our first term is 3x squared. So that becomes 6x when we take the derivative. And then when we take the partial derivative of our second term, the 4y cubed, that's 0 because that would be a constant. All right, so our x term is going to turn out to be 6x in the x hat direction. Now we need to take the partial derivative in terms of y to get our y term. All right, so when we have 3x squared, when we're taking the partial derivative in terms of y, those are all constants. So that term is 0. And then we do the 4y cubed. We would take 4 times 3, which gives us 12, and then that leaves us with y squared. So our term in the y direction would be 12y squared in the y hat direction. All right, so we have our electric field in the x, and we have electric field in the y, but we have a function right now. So our next step is to plug in our terms for x and y. So don't forget there's always the minus sign out front you need to distribute in. So I have a negative 6x, and x is 0.5, so I'm going to take negative 6 times 0.5 to get negative 3. And for the y term, so I have negative 12y squared, so I'm going to plug in 1 for y squared, so I get negative 12 times 1 squared, which gives me a negative 12. All right, so I now actually have a number or value for both my x term and my y term. I can then use Pythagorean's theorem, so the idea that the electric field, the magnitude of it, is going to equal the square root of our x term squared plus our y term squared. So that is how I am going to get the 12.4 here, is I took negative 3 squared plus a negative 12 squared and then took the square root, and that gave me 12.4. And then in order to get the angle, I'm going to use the inverse tangent of the y term divided by the x term. So I would have taken the inverse tangent of negative 12 divided by negative 3, and that gave me 76. And I know it's below the negative x-axis because, as you've seen I've drawn here, both my x term is negative and my y term is negative. So that puts me in the third quadrant, so below the negative x-axis.